So we are comparing the element at the index 3, we have 17. 17 is compared with the key value 17. Each and every element of the list is compared with the key element or the element what we are to search for or what you are looking for. Linear search is name of the function. We are passing the parameter. Here list is the name of the list or the given list along with the key value or the search element. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the new chapter, that is searching. In this session, we are going to talk about what is searching and different types of searching, and one of them is linear search. Let us start with the definition of searching. So what is searching here? So searching means locating a particular element in a collection of elements. So what is searching? You take example like a list. What is a list in Python? It is a group of elements separated by comma, and here if what is searching is a technique or a mechanism where we are going to look for a particular element or particular value in a given list. So that is the locating a particular element in a given list, and here we are going to mention the particular element is at what position or what index it is present in the given list. So the search results determines whether the particular element is present in the collection or not. So here in this example, so we look for a particular element, and if element is present in the given list of elements, then it says that element is present at the index or at the position value. And if the element is not present in the given list, then it results in element is not present or not found. That is the algorithm for searching. So if it is present, we can also find out its position of that element in the given collection. And if it is not present, we can say that element is not present in the given collection. So this is the definition of searching in Python. So what is searching here? Searching in Python is nothing but an algorithm or a technique where the user were looking for a particular element in the given list. If element is present, we are going to display the element along its position, and if element is not present, we have to display the message saying that the element is not found in the given list. This is the definition of searching. Now let us see in programming concept what are all different types of searching: linear search, binary search, and search by hashing. So according to your syllabus, we are going to study 3 types of searching in your syllabus. So these are all types of searching. Now in this session, let me explain you about linear search. One of the searching technique or algorithm is linear search. Let us see the definition of linear search. See, what is a linear search? It is the most fundamental and simplest search method, and it is a technique where the elements of a given element list is compared with the item to be searched, usually referred as key element. So what is a linear search? It is a very simple method, it is a very simple search, and here each and every element of the list is compared with the key element or the element what we are to search for or what you are looking for. That is, we are using the word a key or a key element. So each element in the list is compared it with one by one. So this is the procedure here. So the given key element is compared with each and every element of the given list, and this process continue until an element is matching with the key element, and we declare that search is successful. If no element matches, then we declare that search is unsuccessful. The key element is not present in the list. So this is the algorithm. So here in this technique, the given element, we say key element, is compared with each and every element of a given list. So if this process continue, how long? Till the end of the list is going to compare the elements. And if the element find matching, means the key element, if it is equals to the element in the given list, then we say that element is found or present. We say that we declare that search is successful. If the key element is matches with any of the element in the given list, then we say or we understand that search is successful. If not, the key element what we are searching for is not matching with any of the element in the given list, then we have to declare that so that the element is not present in the given list. So this is the algorithm of linear search or definition of linear search. Now let us see with example. Let us see example 1. So assume that the num list will be having elements 8, -4, 7, 17, 0 to 19 are the elements of the given list, and n is 7. So here, what is the meaning of n here? N is the size of the list. Here there are 7 elements. The size of the given list is 7, that is n equals to 7. So we need to search for the key element, that is phase 17. Now we have to search for the element 17 in the given list. So if it is present, we have to display that the element 17 is present at this index or at its position. Or if element is not present, then we have to display the message that element is not present in the given list. These are the elements given in the list, and these are all the indexes. Index start with, all of you know that in the list, the always index starts with 0. So 0, 1, 2, 3, 4, 5, 6, and here there are 7 elements. So n equal to 7, length is 7, and last index is n minus 1, that is 6. These are the index of particular element in the given list. Now let us start with this example or the process. What is the first process, or in the first iteration? I want to look for 17. So first one is index 0. So this loop is going to continue, or this process continue as long as the length of this or the index is less than the length of the given list. That is why we have to find out here in the beginning the length is 7. So here the loop continues as long as the index value must be less than 7 or the length of the given list. So here 0, first test is we have to check for 0 less than 7. Yes, if it is yes, then you have to proceed that. So we have to compare the given, this is the key element in this example. 17 is the key element. I'm comparing 17 with the 8. So here, as per the definition, we have to compare the given element 17 with each and every element of the given list. So we have to compare 17 with 8, 17 and -4, and so on. So if any of the 17 is matches with any of the element, then you have to make a note of the index and its position. So here now the process is 17 is compared with all the elements starting from the index 0 or the value 8. So in this process, first 8 is compared with 17, the key value, it is not equal. So the index is, we can say the position is 1. So we have to increment the index, or it goes to next iteration or next pass. Next index is 1, 0, 1, 2, 3 are the index. 1 is less than 7, 7 is length of the given list. So as long as this is true, the loop will continue. So here the next element is -4. Next element is -4. -4 compared with 7. These two are not equal. So it has to go for next iteration. So next index is 2, and in the index 2 element is 7. I'm comparing with the 7. Here these two are not equal. So it has to go to the next iteration. In the next iteration, index is 3. 3 less than 7, it is true. So we are comparing the element at the index 3. We have 17. 17 is compared with the key value 17. At this iteration, these two are equal. So it is 17 equal to 17. It is yes. In that case, we have to stop searching for the elements further. So we will stop at this point and we will make a note of the index. So here 17 is equal to 17. It is true. In that case, we will not continue further. We will stop processing or we will stop searching the elements hereafter. So here we will make a note of the index. Index is 3. So index is 3. So here element is found at the index 3. Means the element 17 or key value 17 is found at the index 3. But we want to print the position is always 3 plus 1 or index plus 1, because all of you know that this index always start with a 0. So to avoid this, we are going to add plus 1 to the index. It gives the position of the element. So in this example, 17 is the element, is at the index 3. So we can print the message saying that search is successful and element is found at the index 3, or we can say at the position 4. See, we can say that element is present at the position 4. That is 3 plus 1. 3 is the index plus 1 equal to 4. So element is present at the position 4. See, this is one example of linear search. So what is the definition? We are comparing the given key value 17 with each and every element of the given list from the left hand side or from the starting from the index 0. If the key value is matches with any of the number in the given list, then we have to make a note of the index at this point or of this number, and we have to print that search is successful and element is found at the index, in this example, or index 3 or position 4. And here, if once we find the matches here, we will not continue further for or searching for or comparing for other element in the given list. Now let us say one more example, that is example 2. Now look at this value here. Same, I am taking the same example, same list, 17, 8, minus 4, 7, 0, 2, 19. Now I want to search for the key value. Now I want to search for the value 17, or the key value or key element is 17. So as per the procedure, we have to comparing 17 with this index 17. So 17 is equals to 17. 17, 8. 17 minus 4, 17, 7, 0, 2 and 19. So in this example, we start with the index 0. Here is index less than n. Here, what is the length of the list here in this example? There are 7 elements, length is 7. So this is length of the given list, that is 7. So index 0, 0 is less than 7, yes. We will continue comparing the element. So here the first element, the value at the index 0, 17, comparing with 17, the key value 17. 17 equals 17, yes. In that case, we will make a note of the position. Index is 0 and position is 0 plus 1, that is 1. So this is yes. So when we find the matches here, as per the algorithm, we will not continue further. We will come out of the loop or we will stop executing the program. So we will come out of the loop. Then we had to print the message that the search is successful, and here element is 17 is found at the index 0. So index of 17 is 0, or we can say that it prints the message, or we can say that element is 7 is present at the position 1. So here in the table we can make out this is the index 0 and this is the position 1, or we can say index plus 1. So this is second example, but in this example we could able to find the search element only at the beginning as of the first element itself. So it doesn't require to compare the other elements in the given list. Now let us go for one more example, that is example number 3. So let here the given list is 17, 8, minus 4, 7, 0, 2 and 19 and key value is 10. Means we have to search for the value or element 10 in the given list. So here this is the index and this is again the elements at the particular index. So linear search for key element 10 in the number list given. Now let us start the procedure as per the algorithm. So first we are going to compare the element starting with the index. So first one is 0, index less than 7. Here 7 is the length of the given list. Yes, it is true. If it is true, we have to compare the element at the index 0. So here element at the index 0 is 17, at the index 1 is 18. So similarly, we have to compare all the elements at this particular index value. So here 17 equal 10, no. In this, these two doesn't match, not matching, then this is the position. So as I told you in the previous slide, index is 0, this is index plus 1, it is a position. So this is no, then we have to go for next iteration or next pause. Next element is 8. 8 is compare with 10 because 8 is at the index 1, 1 is less than 7. So we have to continue or we have to compare the elements. So 8 equal 10, no. Again, if it is no, go for next iteration. Next minus 4 is equal to 10, no. 7 is equal to 10, no. So 0 is not equal to 17, 2 is not equal to 17, even 19 is not equal to 17. So in this example, here the key value, that is we are looking for the value 10, it not matching with any of the element in the given list. In that case, we can say that as per the algorithm, we have to print a message or we have to say that the search is unsuccessful, so element is not present. So with respect to this example, 10 is not present in the given list, so we have to print the message element is not present or the search is unsuccessful. Now look at the example here, 10. This 10 is not present in the given list. So this is one more example for linear search. Now let us say this is a program or programming statement. We are defining a function here for linear search. Here def is defining a function. Linear search is name of the function. We are passing the parameter. Here list is the name of the list or the given list along with the key value or the search element. And here the code goes like this. If list of index is equal to key, we have to say return index plus 1. This is what you're comparing the elements here. We are comparing the key element with the values at the index. If it is successful, we have to say index plus 1 or at the position, this position. If not, we have to say return none. So this is end of a function. Next, this is a list. This is an empty list at the beginning. So we have to print here maximum equals to int input how many elements in the list. So this is nothing but we are going to find out the length of the given list or how many elements we have to enter into the given list. So here at the beginning it is an empty list. So this is maximum is a variable. So we have to give the values. Then accordingly print, we have to enter the elements. So we are using the for loop for I in range from 0. Index is 0. Maximum is the length of the given list. And we are going to accept it, input statement, n equals int input list1 dot append. Here we are using append function. List1 dot append of n is the given number n. So these are the statements. Append the element to the list with the help of append function. Then after that we have to print this list. The list contents are is going to print out the list elements. Next one is we have to look for key element or you have to enter or you have to input the element to be searched for, enter the number to be searched. We are calling the function here position equals linear search list1 comma y. Linear search is a function what you have defined here. So here at this stage we are calling the function If position is none, if position is not 0, it is element is not present. Means if none of the key given element is not matching with any of the element in the given list, we have to say that element is not present. Otherwise, we have to print the value along with its position. See, this is the programming statements for linear search. Now look at the output of this. As per the program, so we have to enter, it displays the message how many elements. We are going to enter 4. So we have to enter 4 values. In this example, 12, 23, 3 and -5. Now this is a given list, and now enter the number to be searched for. In this example, we have entered 23. So 23. So in this given list, if you look at this, is 23 is at the position index 0, 1, 2, 3. So it is at the position, index is 1, position is at 2. So accordingly, it prints the message number 23, the key element is present at the position 2. Here 0, 1 is the index, but position is index plus 1, 1 plus 1, that is equals to 2. So this is a program for linear search. Students, so far in this session, we have discussed about the sorting as a definition, types of sorting. We have discussed linear search with examples. Let us continue our discussion in my next session. Thank you very much.